bond strengths and lengths. After you have completed this video, you should be able to explain the differences in strengths behind bonds of different orders, explain the difference in strengths behind bonds of different molecules of different sizes, find the expected bond order of a molecule with resonance structures. There are several things that affect bond strength and length. However, there are certainly some trends we can talk about here. First, let's think about how we should define bond strength. We will define it as bond dissociation energy. In other words, how much energy changes when the bond is broken. If the bond is strong, it will be a much shorter bond. For example, if we take a carbon-carbon bond, a triple bond is much stronger than a single bond, and so it is also much shorter. What about comparing bonds in atoms that are different sizes? The bigger the atoms are, the longer the bonds must be, and this weakens the bonds. So those with bigger atoms, or larger atoms, have weaker bonds. Now let's talk about a special case of bond lengths. What happens if you want to think about the relative lengths and strengths of a bond that is in a structure with resonance? In these cases, the bond will be in between that for the normal structure. For example, let's look at our nitrate that we did last video. Since we know that each bond is made up of not just the single bond, but a shared double bond between all three, we know that the bond order will be somewhere between 1 and 2. We can go further with this and say that we have 4 bonds split among 3 bonding atoms, and so it will be a 4/3 bond order. 1, as in the single bond, 1/3 because the second bond is divided equally amongst all 3 sections, so it's a 4/3 bond order. Now that you have watched this video, you should be prepared to rank bonds in order of strength based on their order, the molecule's size, or in other words, the individual atom sizes, and know where resonance structures bonds would be placed in that ranking.